Welcome back to AP Pre-Calc. This is the start of Unit 2. This is Lesson 2.1, Change in Arithmetic and Geometric Sequences. All right, so here we go. A sequence is a function from the whole numbers to the real numbers. Okay? This means that we can only plug in, or substitute would be a better word, but plug works in my world. We can only substitute in whole numbers, 0, 1, 2, 3, into a sequence, but we can get out any kind of real number. We won't have any i's, so don't worry about that. So when we substitute these whole numbers in and get a real number out, we basically have an input and an output, and we could graph those. We wouldn't connect the graph because we're not substituting in 1.3 and 1.4, and so they're just a whole bunch of dots on a line, but they will form a linear pattern. They're not exactly going to make a line because we're not going to connect them, but they follow a linear pattern. Let's go ahead and look at example 1. Consider the function defined by a sub n equals 4n minus 1. We're wanting to find a sub 1 and a sub 7. So notice that this 1 took the place of the n, so we're going to replace the n with a 1. We're going to substitute a 1 in, and then we just do a little bit of fancy hard math and we get 1. We do the same thing here, and we'll get 25. Okay, pretty simple. So in AP Pre-Calc, we're going to look at two different types of sequences: arithmetic sequences and geometric sequences. Remember, sequence is just a list of numbers, okay? In an arithmetic sequence, we're going to have a common difference between each term, right? Or a constant rate of change. If you remember back into the last unit, when we had a constant rate of change, we had a linear function. If we are given a list of numbers, we can find this common difference. Like if I have 7, 10, 13, 16, we can always take one of the numbers and subtract the number before it. So you could do something like this: d equals a sub n plus 1 minus a sub n. That's just a fancy math way of saying, hey, subtract the number that was before this number in the list. But this way it looks like we're really smart. So over here in the next column, we have the formulas. Last year, we used this formula right here: a sub n equals a sub 1 plus d times n minus 1. Hopefully that looks familiar. That was a great formula to use. It was just a little cumbersome sometimes because we didn't know what a sub 1 was, and then we had to do some fancy work to figure out what the a sub 1 was. This year, we're going to concentrate on this formula down here, because this right here, you notice, look at the difference: a sub k versus a sub 1. This says I can start anywhere in the list I want, and then instead of subtracting 1, we subtract whatever place we are in the list. So if I give you a sub 7 is 20, we'd put a 20 right here and do minus 7 over here, okay? So that's going to be a little bit different, so we got to work on that. So here are some terms that you're going to have to get used to. The a sub 0 is our initial term, so let's write in there initial term. D is our common difference. That should be the same as last year. I'm just going to leave that there. And a sub k is our kth term. So if it said a sub 20, we're talking about the 20th term. Okay? Okay, on the next column over, remember, arithmetic sequence behave like linear functions. They're not lines because they're not continuous, all right? But we will have dots that form a linear pattern. Okay, so let's come down here to the example. We have a sub n equals 3n plus 1. And if I want my initial term, a sub 0, we would just put 3 in there, put the 0 in there with the 3, and we would get a 1. So I could start right here, 0, 1. And then a sub 1. Do the same thing, substitute in the 1, and you get a 4. And I could come up here, put my little dot. And I could keep doing this, and creating this linear pattern graph. I could make this list, and once you see it, you can tell that what the next one's going to be, and you can see that we're just adding 3 over and over. So real quick, if you remember, this kind of looks like the slope. If this looks like it's in slope-intercept form, then that number, the slope, the m, that is the common difference. All right, so whenever you see this number in, it looks like a slope, that is our common difference. So if we can find one number, we could just keep adding that number over again to create our list. Pretty simple. All right, let's take a look at example 2 here. So it's asking us for each of the following, determine whether that could be arithmetic. And remember, to be arithmetic, we have to have a common difference. Well, just by looking at it, you may not know. So let's make a list, all right? So I can do s sub 0, and I could get -3. I'm just kind of doing this in my head. If you need to use a calculator, go ahead. -2, 1, and this should probably be far enough to figure out if we got it. All right, what's the common difference? We added 1, and then we added 2. Well, I can stop right there because it is not the same difference. This is not arithmetic, so not. I'll leave it like that. Let's do the same thing for the next one. S sub 0, put it in, you get 6. S sub 1, you get 4. S sub 2, you get 2. S sub 3, you get 0. Let's see what we got. -2, -2, -2. This one is arithmetic. Okay? And I'm going to be honest, if you look at it, and like what I said earlier, if you can write it in y equals mx plus b form, it's going to be arithmetic. And the first one is a quadratic, so I knew it wasn't going to be arithmetic. But the next one I could write as y equals -2x plus 6, and that's a linear function. I knew that was going to be arithmetic. Let's look at C. All right, well, I added 5. Looks like I'm always adding 5. So that is arithmetic. The next one, I subtracted 3, and then I added 5. I can stop right there, and I can say not arithmetic. All right. In example 3, we get to use our formula that we learned. Remember, it's a sub n equals a sub k plus d minus n minus k. Okay, so let's see what we have here. We're looking for the a sub n formula. So a sub n equals, they're giving me the third term. It's saying it's an 8. So I know that my k is 3, right? So I can put that in here. So put a 3 there. And they also told me that the common difference is -3. So I could put that there, right? And then they want me to find the expression to find the 12, right? A sub 12. So that's the n. The a sub number is the n, the number I'm looking for. So I could say a sub 12 equals 8 minus 3 times 12 minus 3, and put that in our calculator, or do some mental math if you want to, and you can know that a sub 12 is equal to -19. Okay, let's look at example 4 here. So we have an arithmetic sequence. We starting a sub 2 is 7, a sub 6 is 9. Find the expression for the a sub n and use it to find 24. Well, unlike the last one, they didn't give me the common difference, so I really need to find that first. So one of the ways you could do it is you could go and use the formula that we just have, and a sub n would be your last number, like what's the later number. So what came first, a sub 2 or a sub 6? Well, a sub 6 would come first, right? Which would leave a sub 2 to go in the next spot. I don't know this common difference, right? N was 6, we put a 6 there because of this guy, and then I'm going to subtract 2 because of this guy, right? Remember, this was a sub n, this is a sub k, so this number and this number have to match, and I used a sub 2 there. This number and the first number have to match, and I used a sub 6. And now we could just do a little bit of math, and we could get d equals 1/2. And that's a great way to do it. There is a little bit easier way to do it. Learned this from Mr. Flick last year, so I'm going to show it to you. So what we could do is we could make this nice little a sub 2 equals and a sub 6 equals, like we're making ordered pairs, right? 7 and 9. And then we can go, okay, what's the difference here? 2. What's the difference here? 4. And remember, change in output divided by change in input. Well, 7 and 9 were the output. A sub 2 and a sub 4 were the input. So change in output is 2 over 4, which gives us 1/2. Quite a bit easier to do it that way. I was really impressed when he showed me that last year. So after all that, we still haven't answered the question. They want us to know. They want us to find out what a sub 24 is, right? So I need to put a sub 24 here. And you can use either one of these numbers. It doesn't really matter. You can use the 7 or the 9. Just got to make sure that you're using the right K. So I'm going to use the 9. And I know that it is 1/2. And then I'm going to put the 24 here, minus, and because I used 9, this was a sub 6. I'm going to put minus 6 right there. So now I get a sub 24 should equal, well, 24 minus 6 is 18. Half of 18 is 9. 9 plus 9 is back to 18. All right, on example 5, they're giving us a graph, and you can look at that and go, hey, those dots have a linear pattern to them, so this is an arithmetic sequence, but they also told it to us in the question here. So that we want to find an expression for a sub n, right? So what do we need? Well, we need the common difference. So the common difference is how much am I moving on my y-axis? Well, I'm at 8 up here, and my next point is at 6. So that is going down 2 or a negative 2. So let's get going here. We got a sub n equals, I need a starting place, and I can really use any one of these to start with. I like to use a point if it's on the y-axis, and we have one. So we have an 8 plus, well, I don't know why I'm putting plus, because it's a negative. And you could put plus negative too, it just looks weird, okay? And then I'm going to do n minus 0, because 8, my input for 8 was a 0, right? So let's clean that up a little bit. A sub n equals 8 minus 2n. And you would get that whether you picked any of those other numbers. If you don't believe me, do one off to the side and see if you come up the simplified version, like getting rid of the parentheses. See if you can always make 8 minus 2n. So to finish up the question, it says, hey, I want a sub 17. So we can do a minus 2 times 17. That's going to give us 2 times 17 is 34. I think that's going to give us negative 26. All right, let's finish up this lesson with geometric sequences. Remember, arithmetic sequences, they had a common difference, meaning that we were going to add the same number over and over again, whether it be a positive number or a negative number. But geometric have a common ratio. They are proportional. It means it's a fraction. So remember, in arithmetic, we took a number and subtracted the number before it. Well, in geometric, we're going to take the number, so as long as it's not the first one, and then we're going to divide it by the number that's in front of it. So that's how we find our ratio. If you remember from last year, we had it looked something like this: a sub 1 times the ratio to n minus 1, right? That's, again, we had to know what the first term was to put this in the, but it's a little bit easier, I think, to use this one all the time. We did the same thing in the arithmetic. We're just, instead of a 1, we're going to put k. So that means we can start wherever we want to. So this is what we're going to use this year, okay? So just like the last one, g sub 0 would be our initial term. This is the common ratio. And just like the last one, it's the kth term, okay? So in a geometric sequence, the dots, because remember, we're not continuous, we're just dots on a graph. The dots are not straight. They'll actually start showing a bit of a curve, and actually that curve will get a lot steeper as you move out on the x-axis, okay? So let's look at our little box with the example in it. We have g sub n equals 8 to the 1/2. So let's go ahead and just plot some points. G sub 0, 1/2 to the 0 power is 1. 8 times 1 is 8. G sub 1 is going to be 4. G sub 2 is going to be 2. Let's go with G sub 3. That's going to be 1. And all I'm doing is substituting in that number for the n and just doing a little bit of arithmetic, okay? So let's graph it. We got 0, 8, right? 1, 4, 2, 2, 2, 3, 1, and then so this is what it looks like. If you remember from last year, that is like a decay model, and we knew it was going to be decay because our ratio is less than 1. If it was bigger than 1, it would go like that, okay? All right, so it needs to be an exponential function, right? It needs to, if you're looking at the function in function form, it needs to have a variable in the exponent. Okay, so let's look at this example 6. So for a, I get s of n equals 3n squared. Well, that's a quadratic, so obviously that is not geometric. Let's look at 2. Hey, I got a variable up in the top. This is geometric. And we have a r of 2. Just so, remember in the last one I said your common difference is the slope? Well, in this one, your common ratio will be the base. And remember, when I say the base, I'm talking about the number that has the variable exponent, not just any exponent. When I say the base, it is the one that has the variable exponent. And in this case, 2 had the variable exponent. So let's keep moving on to C. All right. I multiplied by 3. Cool. I multiplied by 3 halves. Not cool. It's got to be the same thing every time. So this is not geometric. Last one. We multiplied by negative 1/2. We multiplied by negative 1/2. Negative 1/2. Negative 1/2. Oops, 1/2. So this one is geometric, and our r is negative 1/2. All right, so here in 7, we're given g sub 1, and they're telling us we have a rate of 2, or a ratio of 2, and we want to find the expression for g sub n. All right, so we know that g sub n equals 12. Remember, this is supposed to be g sub k. So I know that my k is 1, and we're going to times r. Wait, I know what the r is, so I'm going to times 2 raised to the n minus k, and in this case, k was 1, so there is my formula, and they want me to find the fourth one. So I'm going to do g sub 4 equals 12 times 2, and I know the 4 is going to go here, minus 1, so that's a 3. 2 to the third is 8. 8 times 12 is 96. All right, last example, number 8. Let's move this up a little bit so we can see. All right, so I have a graph again. All right, and they want me to find g sub n. So I'm going to do g sub n equals, do I know what I am multiplying by? Do I know the rate? Let's put that over here, rate equals. So how do we find the rate? Well, if I wanted to list these numbers out, I could list them out as 8, comma 4, comma 2, comma 1, dot, dot, like that. And you can probably look at it and see it, but I could just take one of those numbers, as long as it's not the first one, 4, and divide it by the number in front of it and get 1/2, right? So I know that 1/2 is going to go here. So now I need some place to start. And again, this doesn't matter. You could pick any of those numbers. You could pick 8, 4, 2, 1, 1/2, 1/4. Doesn't matter, okay? I'm going to pick 8 because I like the one that's on the y-axis, because that gives me a 0 as my sub. Remember, this is This is going to be g sub k, and k being your input. My input was 0, so when I come up here, I can do n minus 0. So I get g to the n equals 8 times 1/2 to the n. So if I want to find 10, I got g sub 10 equals 8 times 1/2, and I want the 10th number. This is going to take a little calculator work, so give me a second. All right, I got 1 over 128. We really don't want that in decimal form. If we can turn them into fractions, that's the better way to show that. All right, that's the end of this lesson.